In this video, we will learn about the zero product property, which allows us to solve equations that are factored and set equal to zero. The zero product property tells us that if we have a product, so multiplication, set equal to zero, then one or more of the factors must also equal zero. For example, if we had 5x equals 0, then we know that x is 0 because our factors are 5 and x, and 5 does not equal 0. If we had x times y equals 0, then we know that either x is 0 or y is 0. Now the word or in math means that one or the other or both could equal 0. If we had x plus 1 times x minus 3 equals 0, then again, at least one of our factors must equal 0. But in this case, each of our factors is actually more than one term. So one of our factors is x plus 1, and the other factor is x minus 3. So we have two situations. We know that either x plus 1 equals 0, in which case x is negative 1, or x minus 3 equals 0, in which case x is 3. So we could say x equals negative 1 or x equals 3 and write that as your answer, or you could write this as a set in a list in brackets. Notice that it is not an ordered pair because it is not a point, it is a set of numbers. Let's do some examples in your notes. So, again, the key idea is that if the product of two or more factors is 0, then at least one of the factors must be 0. We have to have an expression that is factored, meaning it is a multiplication problem, hence product, and it must be equal to 0. So, I can separate each of my factors. Looking at this first example, my factors are x and x minus 2, because we have x times x minus 2 equals 0. So I know that either x is 0 or x minus 2 is 0. In this case, I'd add 2 to both sides, and I'd get 2. So my solution is x equals 0 or x equals 2. You might also see this in a set, x equals 0 or 2, written like that. We could check this, knowing that if we substitute our solutions into the original equation, then we should get 0. So instead of x times x minus 2 equals 0, we'd have 0 times 0 minus 2 equals 0. That's true. Or instead of x times x minus 2 equals 0, we'd have 2 times 2 minus 2 equals 0, which is 2 times 0, which is also true. You should always be able to check your solution, even if you check it using mental math. Next example. We again have two factors, two binomial factors. We have x minus 8 times x plus 1. So either x minus 8 equals 0 or x plus 1 equals 0. In this case, we would add 8 to both sides and get x equals 8. And in this case, we would subtract 1 from both sides. We get x equals negative 1. So our solution is x equals 8 or x equals negative 1. You'll start to notice that a lot of these could be done, again, using mental math. I'll let you check it or check it using mental math. In the next example, we have factors of 8, 3x plus 1, and 3x plus 1 again. I could certainly write this out as 8 times 3x plus 1 times 3x plus 1, but you'll notice that we're going to get the same answer if we set this factor or this factor equal to 0. So although this affects the shape of the graph, it will not affect our solution on the graph. So we would set each of our factors equal to 0, but we know that 8 doesn't equal 0. However, we can do 3x plus 1 equals 0, subtract 1 from both sides, and then divide both sides by 3 to get x equals negative 1/3. In this case, there is only one value that will make this expression equal to 0, and it is negative 1/3. Time for our final example. There are a lot of factors here. We have a factor x, 1/2 x plus 5, 1 minus x, and x squared minus 9. So we know that x could equal 0, 1/2 x plus 5 could equal 0, 1 minus x could equal 0, or x squared minus 9 equals 0. Pause the video and try to solve this on your own. I end up with 5 possible solutions. X equals 0 from my first factor, or x equals -10 from my second factor, or x equals 1 from my third factor, or x equals 3, or x equals -3. Don't forget, since we have this x squared here, we have 1, 2, 3, 4, 5 x's, so we need to check for a maximum of 5 solutions. Sometimes, like in the previous example, we end up with the same solution more than once, or if we have a number that isn't 0, we know that that won't give us a solution, but the number of x's, in this case x squared, tells us how many different solutions to check for. You might be wondering why this is useful. This is useful because in a lot of problems in Algebra 2, we end up graphing using intercepts, and the x-intercepts become really important. If we're looking for an x-intercept, we know that we can substitute 0 for y and solve. In this case, we'd get that x is -3/2, right here. But when we're dealing with things that are not linear, the x-intercepts become even more useful. So this equation I've written in factored form right here. And so I can see that my x-intercepts are x equals -2 and x equals 3, because my solutions when y is 0, which is how we find x-intercepts, are -2 or 3. A lot of times you won't be given the equation in this form. You'll first be given it in this form. Y equals x squared minus x minus 6. And you will have to use your new knowledge, which you'll gain soon, of factoring to get from here to here, which will then allow you to solve using the zero product property. But that is a goal for next time.